Hello. What I want to do in this video is to talk about the different types of energy that there are and give you an overview of that. So we're looking at different manifestations of energy. Energy allows us, transformations allow things to occur, right? We live because, well, there's energy transformations in us that allow us to take the energy from food, okay, so that my heart can beat, I can move around, and I can give this video lecture, right? Similarly, we can burn things and that transforms it into light and thermal energy, okay? And then the other thing we have over here is in transportation, right? This is some sort of electrical energy. The particles then move, right? And allows the trains to move. So, how do we classify it? And there's a number of different ways we can classify it. And this classification is not complete, but hopefully the goal here is not just to give you, a full list, not so much to give you a full list as to give you a sense of what forms of energy there may be and how we might think about that. So the big division between different forms of energy is kinetic energy and potential energy. So in terms of kinetic and potential energy, the big thing, of course, is kinetic means moving. So kinetic energy involved is the energy associated with something moving. And potential energy is the energy stored due to essentially either the structure of something, okay? So it can be in the form of fuels, okay? That would be nuclear or chemical structures. But it could be, for instance, for elastics, right? Like this bow and arrow here, this would be because of the arrangement. So it's generally because of the arrangement of matter. That would be a more general description. Pulling it apart so that taut spring stores that elastic potential energy. On the top of here, the guy at the top of the hill has gravitational potential energy. Okay. Within this, if it is a macroscopic form of energy, for instance, the kinetic energy due to my whole body moving, okay, or the potential energy due to the whole something macroscopic, say this bottle here, up here, there's a certain gravitational potential energy, right, which converts to kinetic energy. Okay, and one thing to note then is these are forms of mechanical energy, which means it is basically mechanical energy is basically the kinetic and potential energies of macroscopic things. What I want to do now is kind of break this down a bit more. So electrical potential energy, okay, is the energy associated with the movement of charged particles. Within here, okay, in a battery, what really happens is that we are separating out different parts of a reaction so that it stores it basically as chemical potential energy. And I'll talk about that in a bit. But the big idea here is then when it's separated out, when you put it together in a wire, it allows charged particles to move around this system. In the wires, it will be electrons. In here, it will be ions. But the big idea is there's movement of charged particles, and that is what we mean by electrical energy is the energy associated with the movement of these charged particles. The other one, of course, is chemical potential energy. As I alluded to already, the battery in there has that because basically you are allowing, essentially harnessing a certain types of chemical reactions to force this reaction, to use that reaction to drive the motion of charged particles. A more common form, of course, is if I burn something. Okay, I don't feel like setting off my fireplace tonight, but definitely the energy in food that would definitely be chemical potential energy. In the firewood, yes, or gas, all different forms of chemical potential energy, where the energy is stored in terms of the molecular structure that is released when you have a chemical reaction occur. The other thing, of course, as we alluded to before, is the gravitational potential energy. Again, something goes from up to down. It can go from up to down, right? So right now, this is hanging up here, and this would be the gravitational potential energy relative to here. When I release this, there's kinetic energy. On a grander scale, we have this waterfall over here, right? And on this waterfall, of course, the water up here, up top, would have a greater, over here, would have a greater gravitational potential energy than down here at the bottom of the falls. Now, of course, when you're at the bottom of the falls, then the water will move much faster because that energy is transferred into kinetic energy. Talked about before, elastic potential energy. You've played with rubber bands before. When you pull it apart, it kind of gets tight, and when it releases, it speeds up, right? So that energy is based on the arrangement of the molecules in the elastic. Kind of pulls the material apart because it arranges the molecules in that way, macroscopically, sort of. And then that transfers it to kinetic. When, say, you have a bow and arrow and you let the arrow go. And of course, there's nuclear energy, where the energy is stored in the form of a less stable nucleus. And that allows, of course, for us that energy is released, say, in a nuclear power plant, or in a nuclear bomb. Or, in the sun's case, sunlight. One form of kinetic energy I kind of want to point out is the idea of thermal energy, which is the energy associated with random motion of molecules. Okay, this is proportional to the temperature. And so when it gets warmer, the molecules in the air, everywhere, the random motion, right? All the air molecules out around here are moving randomly. There's no wind in this room, right? Hopefully not. And they're moving randomly, and their motion, the energy associated with this motion, increases as the temperature increases. Okay? Thank you.